Well, good morning and a warm welcome here. My presentation is entitled New Copper Microcapsule Formulations, or CuCaps, to Combat Downy Mildew. Yesterday, I already talked about the manufacturing process. Today, I would like to talk about the microcapsules as such. When I mention microcapsules, what springs to mind are very small spheres that contain some kind of substance or something. And in the world of science, this type of capsule is called the core envelopment capsule. So with the active ingredient at the center, and in green you've got the envelope. But there is a second basic structure where you cannot really see a clear dividing line between the envelope and what's inside. The active ingredient is blended together or forms a matrix with the surrounding material, with the carrier material, and this type would be called a matrix capsule. In English, it's called microspheres. So they don't use the term capsule as such. However, for our purposes, I still think microcapsule is very descriptive. Now, the structure of this sphere or capsule also, of course, is instrumental in how the release mechanism works. So the core envelope capsule, if you take this, if you put it in your mouth, then the capsule will melt and then the active ingredient will be released in one go. You know, it's like when you have a spirit-filled chocolate, for example, you gain access to the inside all of a sudden. Now, your matrix sphere is like a candy, really. So if you take it in your mouth, it takes a couple of minutes. And for this duration, you will actually have the fruity flavor on your taste buds. So they have a longer effect. So what we need to go for, because we need this to produce the same long-lasting effect, we are going to use the matrix spheres. And that is what CuCaps are. These are solid lipid capsules that are filled with the active ingredient in a matrix. Now, you can see it here in a blue powder, and in order to release that powder agent, the powder has to be dispersed in water. Dispersion is important. It's not dissolved in water, but dispersed. So that is what I always tell my students, because a solution would mean that the capsule would vanish, would disappear. In that case, you don't have to use a capsule from the first. You want to really disperse them in water. Actually, you can tell that something's been dispersed because the dispersion looks opaque. So CuCaps, in other words, are a lipid powder that can be dispersed in water. And we need this to combat Plasmopara viticola, but we don't just use it to defend against these pathogens, but others as well. Now, I've shown this yesterday. I'm not going to give you the details, but actually somebody pointed out something valuable. Somebody said, don't call this spray cooling, but call it low temperature encapsulation. And I like this because I thought, well, you got the key message. Bravo, because we require less energy. The temperature level that we need for our process is lower. We are interested in producing a product that's sustainable, hence the manufacturing process should also be sustainable. And that is why we should call it low temperature encapsulation. Now, you will find a spray congealing actually in the expert literature. Now, since I'm faced with a lot of practitioners in this room, let me talk about what actually happens out there in the field. So, in the year 2022, there was this field study undertaken at the University Geisenheim by Mr. Baus. So, they tested it under the relevant regulations. They used non-encapsulated copper, 3 kilos or 2 kilos respectively per year, and they contrasted this with the CuCaps. That was a synthetic product. Now, this would might be a no-go, of course, for organic viticulture. But what is interesting in this study is that the CuCaps, in any case, it can keep up with the copper treatment. So 2 kilo CuCaps and 2 kilo copper. Actually, non-encapsulated copper will actually perform worse. And if you look at the relative effectiveness, you can see that you can still compete even with 3 kilograms of copper. So and that is our message. CuCaps are very powerful on the grapes, but of course they don't always have the best effect on the grapes and the leaves. Now, because Mrs. Wohlfahrt is not going to speak today, there's an extra chart or a slide that I built into my presentation. So what about the demonstration operations? Now, the Kronenhof estate by Mr. Hartingen, they also conducted a test on leaves and on grapes. So, in other words, under proper conditions, real conditions, not just as part of a strategic trial. And in this case, they looked at the infestation frequency on the grapes: 3 kilo non-encapsulated copper, 2 kilos non-encapsulated copper, 2 kilos of CuCaps. And if you read up on the stats, there will be a lot of different abbreviations. So CuCaps performed best in terms of infestation frequency, better than the 2 kilo of non-encapsulated copper, and the 3 kilos also performed slightly worse. Let us look to the infestation severity. That was also plotted, and you can see the CuCaps in comparison with the non-encapsulated copper. Now, based on the different acronyms, you can see how the CuCaps performed quite well, in fact. So they're in the same league as the 3 kilo of copper because A and B, it says here, but that probably is due to the large standard deviation. But if you look at the height of the bar, that at least they don't perform any worse compared to the 3 kilos of copper. Which brings me back to my slides, the slides that I know much better. I don't really know that much about processes. So how can you save on copper, on the active ingredients? I mean, that is, of course, the big question. And I believe there are 2 important ways to approach this. Firstly, you want to use it at the right point in time, and that is where Vitimeteo really comes in very, very usefully. So when do you need to spray? That is the first question. And the other one, that will be our task. We only want to release the amount of copper that is absolutely necessary. And just to show you how these CuCaps work, I've brought along an animated video. You can see a CuCap on a vine leaf, larger than life, of course. So when it starts, you know you need leaf humidity. So this could be rain or dew, for example. And this water will then wash out the copper from the CuCaps. So what you get, in fact, is the copper 2+ ions on the vine leaf. And that is the actual effective ingredient that will fight your pathogen. In other words, by using microencapsulation, or these spheres, we've used a release mechanism, or we've set up a special release mechanism in order to fight the pathogen. So it was specially adapted to this pathogen. We know that some humidity is required for the process. Now here you can see how the active ingredient is actually released over time. And we conducted a test with potted plants at the University of Geisenheim. So what did we actually do? At different points in time, we applied the CuCap agent, unencapsulated and as capsules. So 5 days and 3 days and 1 day beforehand. And you can see, again, the infestation severity on the y-axis. So the longer or the earlier the CuCaps had been applied, the more copper was released over time or was washed out, and the more copper is released, you would expect less severe infestation. And that is what you can see here. The green bar here in the CuCaps is the smallest one. And if you've applied it for 5 days, of course, you'd release more copper compared to a release time of 3 days or 1. So that is what you can see here if you look at these droplet-like structures. If you remember the picture I showed you earlier, this one here. Now, for the CuCaps to really take their effect with time, one important condition must be in place. The capsule will have to adhere properly to the leaf. If that doesn't happen, the release mechanism cannot work. It would take place in the soil, but it has to happen on the leaf. And that is why it's crucial that the substance adheres, adhesion. So we looked at this adhesion. And if you observe this and how it all starts, well, first, the wine grower will take their spray agent and traverse the different vine rows and apply the spray mixture on the vines. And within the water droplets, you will find the CuCaps. Now, as you can imagine, the flatter the semisphere is, the better this droplet will adhere to the leaf. Now, in lab conditions, we checked up on this by conducting contact angle measurements. And you can see it here. The water droplets containing the CuCaps are actually flatter on the leaf compared to water. So in this case, you can see the underside of the leaf, by the way. So the droplet is flatter compared to the water droplet on the right. And if you compare the upper side and underside of the leaf, we were able to observe that the adhesion of the droplets to the leaf actually works better on the underside of the leaf. On the underside too, that is where infection would take place, where the zoospores would actually penetrate the leaf. So good wettability on the underside is an advantage. Now, we also thought about a wax layer on the underside because the underside will actually repel water, the lotus effect. But actually, vine leaf is not as water repellent as you may think. Now, this sort of thing can be classified. You can look at the contact angle. Now, actually, the surfaces of vine leaves actually are quite hydrophilic, not hydrophobic. Now, if you look at the sprays, and once that's dried off, the CuCaps will remain on the actual vine leaves, and since they contain, or they actually consist of lipids, the lipid or the fat will melt onto the surface of the leaf. It's a bit like pop knobs on rock in a sea, for example. It's comparable. That is precisely what will happen. You can now examine the melting behavior of the capsule, so you can actually adjust it in such a way that it will properly adhere to the leaf or the grape, respectively, and that is how we can improve the whole process. Now, 1 or 2 more slides on the theory. Now, a powder like this also needs to be investigated and assessed with regards to its properties. So the stickiness of the powder, you conduct powder rheological tests. So you place the powder into a small container, you stir it in order to find out how well it mixes. You also look at the flow coefficient that you want to determine, or flow properties. So what is the key message here? You can classify the powder according to freely flowing or a non-flowing powder. That really is a sticky mass mostly. And you can see that the CuCaps are a pretty cohesive sticky powder. Now, in terms to adherence to the leaf, that is an advantage. When it comes to storage properties, however, you might want to add some agent in order to make it easier to apply or spread. so that it can be properly dispersed in a water mixture. Now, this brings me to an idea that we developed together with Herr Bauers of University Geisenheim last October. So we had a little bit of a think on these subjects and thought about the active ingredient copper that was contained in the CuCaps. And since we have our contacts with the food industry who are interested in marketing this in Europe and outside of it, after all, that we have different rules that apply in Europe and the rest of the world. And given these active ingredients, there might be an easier route. So we did a bit of a brainstorming and we wondered whether we could actually reverse the process. So what is meant by that? Let's take empty capsules. Now, you may wonder, why would you choose empty capsules? Well, the effectiveness that I explained, the effect that I explained, is actually based on the fact that it's a sphere or a capsule and that the release process is slow. So we have the empty capsules and you can see these white dots. And these empty capsules, we put them into a copper spray agent, and different ones are available, not just with oxychloride and copper sulfates and things like that. So you add the capsules, you leave them in the agent for 1 hour. The capsules will be able to absorb copper. Now the dots have turned blue. And the solution is pale blue, so not all the available copper was actually taken up, but a certain portion. So some free copper is still in the liquid that you could use, but you've also got copper that's now integrated into the capsule. And you now put the whole mix into your spray equipment. So you no longer have simply a plant spray agent, you have a mixture. The question is, can you actually improve the efficacy this way? Now, we've come up with some new pictures here. Now, this is what the empty capsules look like at first. Now, in the middle, you can see the empty capsules, and in between, the small ones here, this is not contamination under the microscope. These are the copper hydroxycrystals. And after 24 hours, you can see there's slightly less of that. And if you put this into a concentrated copper solution, you can see this on the next solution. You can see some blue margins around it. So you can see that over the time, the empty capsules will take up the copper. These can then be used as a copper deposit, which will be released over time. So in the left, you can see a suspension containing empty capsules, and in the right, you can see empty capsules with a copper hydroxide containing spray agent. I don't really want to advertise here. We have a high level of sustainability, so mixability is very good, 93%, and we've taken up 2 kilos per hectares and year. So that is the kind of mixture we're hoping to achieve. So both methods can be combined. So we tried it out with 6 grams per liter, and that will be more or less the amount that we will use with the CuCaps. The question is how little we can use at best, actually, of this. But that is something we'll have to investigate and try out. Now, this has brought me almost to the end of my presentation. What will be new with regards to the year 2025 regarding the lipid microcapsules? Now, the pure copper content was increased to 10%. Up until now, it had been 4%. In other words, we can reduce the number of CuCaps we need by 60% if they contain pure copper, 10%. Another wish that's been formulated was to combine the pure copper with sulfur, and that can be done. So we had CuCaps with 10% pure copper and 5% sulfur. Now, whether that will work in field application is something we have yet to work out, but we complied with that wish and tried it out anyway. And lastly, the empty capsules approach. Now, because we have a lot of organic farmers here, a lot of organic wine growers, I've brought along this slide. Now, this is courtesy of the University of Geisenheim. This time, Frau Berkelmann was not involved, but Frau Reinecke. So what is this about? Now again, this is about lipids, microcapsules, but in this case we use fragrance herbivore-induced plant volatiles, HIPVs. Now these are substances that are actually given off by infested vines. So these substances will be actually reinforced within these fat capsules. This way we want to attract useful fauna and or flora, and hopefully we will attract also insects that will also fight pathogens. I realize that this is not one of the chief problems that winegrowers are grappling with, but this is an important contribution towards making viticulture more organic, more sustainable. And that is why I believe this is one important jigsaw piece, not the most important one, but certainly one that will help us to reinforce our organic practices. And this could also be, of course, an important part of low-input farming practices. So this was my presentation. So let me summarize. CuCaps are fat microcapsules containing copper sulfate and copper phosphate, which, under the effect of water, will release copper ions slowly and continuously. We heard about the release dynamics. Now we looked at that by looking at the wettability of the leaves. We heard about the strong wettability, especially on the underside of the leaf. We also looked at the berry, and we thought that the best effectiveness can be seen on the berries. We've come up with new formulations containing 10% of pure copper, and the empty capsules were used as additives, and we believe that this is a promising approach, a promising path for the future. So we do need to set ourselves tasks for the future. Therefore, this is my outlook. Now, of course, we want to optimize the adhesion characteristics with the fatter lipids we use here, especially with regards to precipitation. Now, this, of course, could also be useful for other applications, not just in the vineyard and for organic farming practices or low-input farming. We want to combine this with different copper spray agents, and there are different ones available. So a combination of the microcapsule. So we want to see whether this will improve or perhaps deteriorate the effectiveness of the treatment. Next, we also want to investigate this as part of a tank mix, because normally, of course, the wine grower will not just spray copper, but other agents as well. So we need to look at that. And what is important for us is that the microcapsule technology, or the microspheres, we want to develop this further for organic viticultural practices, but it will also play a very important role in low-input farming. That's important not just to us, but also for industry overall, which has brought me to the end of my presentation. Thank you ever so much for listening.